This is the fourth and last part of my naming sequence. We're going to be talking about molecular compounds. Now, before we get too in-depth with molecular, let's summarize what my previous videos have been so far. So in part 1, we talked about how metals can have a fixed charge. In part 2, we saw that there were some metals that have a variable charge, which means that they can have multiple charges. And in part 3, we talked about polyatomics. Now, the thing about all of these three different parts is that this is all ionic bonding, which means that we have a metal, which is found on the left side of the periodic table, bonded with a non-metal, which is found on the right side of our stair-step periodic table. Okay? Now, that's why we have so many different parts and different rules, because there's a lot more metals on the periodic table, so we have a lot more rules. There is a fourth type of naming, and it's for molecular compounds. So this is when you're working only on the right side of your stair-step. You're bonding multiple nonmetals together. Then we can call it a molecular compound. Only two nonmetals. Now, let's get some format stuff. So if we're writing the name, first I want to say that there are some common names for molecules that we see on a regular basis. For example, H2O, hydrogen can behave as a nonmetal, oxygen is a nonmetal. We have a common name for that to be water. Similar case for CH4, carbon acting like a nonmetal, carbon a nonmetal, we can call that methane, and NH3, we can call that ammonia. These are three common names and for common substances that we see on a regular basis. It would be a good idea to memorize those formulas and those names. Now, when you have substances that are not so common, we follow this format, where we include a prefix at the beginning, and then our first nonmetal name, and then we take the prefix and our second nonmetal name, and similar to all our other cases, we end it with an IDE ending. Now, I will comment that this prefix right here is not used. We can omit it. We don't have to input it if it's mono. And we'll see some examples like that. Now, what does mono mean? What are our prefixes? Let's go ahead and talk about a list of them. So our prefixes, if we have one atom, then we call it mono. If we have two, we call it di. 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, and 10 is deca. So, here's my formula. If I'm writing names from this, I need the prefix of the first nonmetal name. Now, what does the prefix tell us? The prefix tells us how many atoms we have shown in the molecule. So, for example, if I'm looking at CO2, I have 1 carbon and 2 oxygens. So, I would say, okay, 1 carbon is mono. Well, we don't use it here if it's mono. So we can just go ahead and start with our first nonmetal name. So this is carbon. I don't include the mono part for the first element. Now, I have 2 oxygens. Well, 2 is di, so I'm going to say di. Then oxygen with an IDE ending would turn into oxide. So carbon dioxide, that's the stuff we exhale when we breathe out. Hopefully the name sounds familiar. Now you know what it comes from. All right, this next one, 2 nitrogen, so we have di-nitrogen. We have 4 oxygens. 4 is tetra. Oxygen would become oxide. So tetra, oxide. Now, just as a minor detail, it's kind of hard to say tetraoxide. This 2 vowel part right here makes it really hard to come out of our mouth. So you'll often see it, they just drop the A. So they say dinitrogen tetroxide. Nitrogen tetroxide. They just drop the A. Minor detail, but it helps it it makes it easier to say. And then here, PCl3, so P is phosphorus. I only have one of them, but at the beginning, if I have one and it's mono, then I don't use the prefix to start us off. So I'm going to start us off with the name. P is phosphorus. Chlorine would become chloride. I have three of them, so I'm going to use tri. So this would be trichloride. Perfect. If we're writing the formulas, it's the complete opposite. So it will give us prefixes that tells us how many of our atoms there are for a particular element. So sulfur, hexafluoride. Well, I don't have a prefix in front of sulfur, which means that it was that mono that was left off. I'm going to put sulfur. Hexa is 6, so I'm going to say fluoride, and there's 6 of them. Carbon monoxide, all right. Carbon, there's no prefix in front of carbon, so I can just write it as is. Mono, mon, means 1. So I have 1 oxide, so I have O1. Or I don't even need the 1, I can just do CO. Nitrogen, I don't have any prefix in front of that, so it's just the N. Dioxide, well, di is 2, so I'm going to say NO2. This last one, diphosphorus pentoxide, so the di is 2, and it's referring to phosphorus, so I have 2 phosphorus. The pent is short for penta. Again, we have that A and the O together, so we drop the A. So we're going to go 5 of my oxygen. So P2O5. This is it's easiest for students to grasp for naming nonmetals. Now, the thing that makes this hard is now that you know all these prefixes, anytime you see something like, what's a good example? Anytime you see something like this, you're going to be tempted to say iron trichloride. That is not the name of it, though. We only use prefixes if it's a nonmetal and a nonmetal. In this case, because we have a metal, we have to use the naming rules for our metal. And because iron is variable, this would be iron with a Roman numeral 3 chloride. Okay? We use this notation if it's ionic. We can only use our prefixes if it's nonmetals bonded to nonmetals, which is a molecular compound. Alrighty, that wraps up my naming notes. I hope that was helpful. Good luck.